Dear students, a very good afternoon to all of you. I welcome you to this session of Design Analysis of Algorithm. This is your lecture number 1, as we have done the introduction in the earlier part. So in this section, we will be doing the contents. We'll start with the contents. So algorithm was coined by this person, Abu Jafar Muhammad, in 825 AD. Fine. So after his name, the algorithm was coined. The algorithm is a term which was given by Abu Jafar Muhammad in 825 AD. Okay. Your subject, it comprises of 3 words: design, analysis, and algorithms. See, we are given a problem for which we are supposed to find the solution. We have been given a problem for which we have to define the solution or design the solution. In coding terms or in computer science terms, we are required to write a program. We are required to write a program for the solution of the problem. For the solution of the problem. Fine. We are required to write a program for the solution of the problem. But before writing the code, we need to understand what is problem all about. Fine. So that means we have to write the algorithm, that is blueprint in your simple English language in order to understand the solution of the problem, what it is giving you. There could be number of ways to solve a particular problem. So that could be A1, A2, A3, A4. Fine. So there could be number of solution to a given problem. So we will write algorithm A1 for the same problem. We will write algorithm A2, A3 and A4. Fine. There are 4 ways or 4 techniques to design an algorithm for the given problem. Now, we have different designing techniques which are available in our subject, just like greedy method. I will write short forms. Then it is backtracking. Then it is branch and bound. Divide and conquer. There are multiple techniques which are available in our subject to design the solution for the given problem. Suppose we are designing A1 with greedy method, A2 with backtracking, A3 with branch and bound, A4 with divide and conquer. This is called designing of algorithm. When you use the different techniques in order to provide the solution for the given problem, this is called designing. Now, after making the 4 algorithms for which we want to code, which program out of these 4 which would be the best, for that we will code. Now, how you will say that this algorithm is best? For that you have to do the analysis. For that you have to analyze the algorithm step by step in terms of space and time. You have to analyze the analysis of algorithm is done in terms of space and time. Or you may write here, analyze the algorithm in terms of space and time. Out of these 4, what is required is less time and less space in the memory. Less memory we can say. The algorithm which will take less time to execute, that means it would be fast, and if it take less memory, that means it can work efficiently because memory fetching times would be reduced and it will make the program faster. Fine. Because you are going to fetch the values of the variables from the memory itself, and this will make your program faster. So what is desired? Less time and less memory to be occupied by a given algorithm. Out of these four, A1, A2, A3 and A4, which will take the less memory or less space, we will design the code for it. We will design the code for it. That means designing an algorithm means we will write step-by-step procedure in the plain language, in any language you understand, using different techniques. You will design the algorithms, and after the designing of algorithms, you will analyze them in the terms of space and time. Whatsoever the algorithm will take less time and less memory, we will design the code for it, we will write the program for it, and later on, see, after the implementation, you have decided for which algo you are going to write the program. Suppose it is A4. Now this is the algorithm. You have to use some data structures along with the algo, and finally you will make the program code, a formal code. This is your informal code, which is written in any language, and using the data structure you will write the program code, and it would be a formal one. After the program is being written in any language, then you have to check or test whether the time and space taken by this algorithm is same, taken by this program is same as you have analyzed while doing the space and time analysis of this algorithm. Okay, so this is how you will check or test after it is being executed. Okay. Now, what is exact difference between algo and program? It is blueprint or informal piece of code. Informal piece of code means you can write it in any language which is being understood to human beings. Program means formal language or a programming language. That is, the code has to be in C, C++, Java, Python, or any high level language. Okay. This is done in the designing part because you can have the multiple solutions of the single program problem. Here, once you have decided which is the optimal algorithm, you will do its code. That is, it is done at the implementation part. This is done in the designing phase. This is done in the implementation part because you have to implement the algorithm. Once you have selected this is the best algorithm, you are going to implement it. Okay. So next, here only the person requires the domain knowledge, means he should know how to solve a given problem. Okay. Here the person has to be perfect in the programming language. Programmer, he should be a programmer, good programmer rather, to implement the algorithm into the program. Okay, he should convert the simple language algorithm into the program. So he should be a good programmer. Here he can have only the domain knowledge. Okay, next, your algorithm is always hardware, comma software, comma operating system independent because you are writing it on the paper. It is always hardware, software, and OS independent. Here it is because you have to install the programming compiler before you run it. So you need to have hardware, software, and OS dependency. That means your code will be dependent on the hardware, software, and OS. Okay. Next, once you are done with the algo, you need to analyze. Once you are able to finish up the algo, you need to analyze the algo in terms of space and time. You need to analyze the algorithms in terms of space and time. Here, you will check, verify, or test the space and time after implementing or running the code. After implementing or running the code. Once you run this code, you have to verify or test the space and time that would have been taken by the algorithm is same or little bit variant. That is allowed, but not much variation should be there. Okay. So this is how you will choose a particular algorithm to solve a particular problem. First of all, you have the problem, you will design the blueprint. Then you can have the multiple solutions for the given problem. You will devise the algorithms for all the solution. Then you will analyze them in the terms of space and time. And then you will finalize for which algorithm you are going to design the code. For which algorithm I am going to design the code that is dependent upon my choice, upon the solution, upon the analysis in terms of time and space complexity. Okay. Next, there are again two types of analysis. One is priori analysis. Another is posteriori analysis. Priori analysis and posteriori analysis. I'll write it with the posteriori analysis. Okay, those two types of analysis are there. One is priori analysis and second is posteriori analysis. This analysis is done during the algorithm designing part. That means before the implementation of the program, during the algorithm designing part, and this is done after the program or algorithm is finalized and program is made, after the program is made or during the program is into the process. You will write during the program in process. Okay. So again, here we require the algorithm, here we require the program. For prior analysis, we need the algorithm. For posterior analysis, the algorithm needs to be converted to the program. Next, algorithm is independent of the PL. That means no knowledge of any independent of the knowledge of PL. That means only domain knowledge will be sufficient to do this kind of analysis. Here we require good programming knowledge. See here, we need not any hardware. We do not need any hardware for the algorithm. Do not need any hardware or software to understand the algorithm. But in order to understand the program, whether it is working or not, or it is deviating from its output, we need the programming language, which would be dependent on hardware and software. Okay. Then in prior analysis, you will analyze the space and time complexity. Here, you will verify or test the size in bytes and time in seconds, right? That means you are going to confirm what you have analyzed here. Here I am analyzing the space and time. Definitely the space will be in bytes and time will be in seconds. Here I am going to verify or test the size in byte and time in seconds or milliseconds. Whatever would be the output, right? So this is how you will perform the posterior analysis and prior analysis. Okay. Next is characteristics of an algorithm. What are the various characteristics of an algorithm? First, input. Second, output. Third is definiteness. Fourth is finiteness. And fifth is your effectiveness. So there are 5 characteristics: input, output, definiteness, and finiteness and effectiveness. Now input is algorithm must take rather 0 or more inputs. Should take 0 or more inputs. Output means the algorithm must give at least one output. Every algorithm should give at least one output. Now, definiteness is there should not be any no ambiguous statement. Means ambiguous means which is having dual meaning. So no ambiguous statement should be there. We should not write any statement which computer is not able to solve. That means if we are human and we cannot solve any statement or any kind of mathematics, we should not give it to computer because it is also not going to solve. For example, if I say integer divided by integer will give me integer. But if I say 5 by 0, 5 is a integer, 0 is also a integer. But it will give me an exception because it does not have infinity to deal with. So this will violate the definiteness. So don't give this kind of inputs to your system. What you can solve could be the input to the system and it should give me the result. Okay. Next, finiteness means algo should have finite number of steps. And it must have a terminating condition. And it must have a terminating condition. That is, the algorithm should have finite number of steps, means it could have 1,000 steps. There is no problem. 10,000 steps is also allowed, but it should terminate somewhere. It should stop somewhere. We should provide the termination condition to the algo. Fine. That means every algo should be finite in nature. It should execute in finite number of steps, and it should have some terminating condition. Now, effectiveness. Effectiveness is nothing. That is, the program. Actually, our ideology in design and analysis of algorithm is to find the algorithm which is best or which is efficient in terms of time and space complexity. That means in effectiveness, we will also look for an algorithm which is efficient, in terms of space and time. That means it should be effective in terms of space and time. It should take less time and less space to execute. That is what effectiveness is all about. Okay. And next condition, it should also be able to solve the problem. It should also be able to solve the problem in the given context. In the given context, your program or your algorithm, effectiveness of program means or algorithm means it should be able to devise the solution to a given problem in the context. Whatever problem is being given to you, your algorithm should be able to devise the appropriate solution for the given problem in terms of space and time. Okay, so these are the characteristics of the algorithm. So in nutshell, we can say an algorithm is a step-by-step procedure to solve a given problem. Fine. Or it is a sequence of computational steps that will transform the input to the output, or it is a finite set of instructions, if followed in order, will accomplish a particular task. For example, any program which is given to you, any problem which is given to you is a task for you. So we have to design the finite set of instruction which, when would be followed in a particular order, will give us the solution to a given problem. So that is called algorithm. So these are the three definitions, and meaning of all is almost same. Here it is saying it is a sequence of computational step, means you can calculate the things whatever are required to transform the given input into the desired output. Then it is a step-by-step procedure to solve a given problem. This is the layman language definition, and these are little more technical. Fine. So this is how algorithm is there. From this, we are clear that algorithm lies between problem which is given to you, and after the algorithm is decided, see, a problem is given to you, you will devise the algorithm, and the algorithm which is best in terms of time and space complexity will be converted to program. Okay, so first of all, there is a problem, then there is an algorithm, then we will convert that algorithm using the programming language into the program. Okay, after that, the program is being done. Here the analysis is performed. Here the verification of time and space is done. Okay, here the verification of time and space is done. Now, There are two questions while after designing the algorithm. First, whenever you're given any problem to design an algorithm, there are two questions which comes to everybody's mind: how to analyze a given algorithm, fine, or how to design it. First of all, how to design an algorithm. Second, how to validate an algorithm. Two questions comes to the mind: how to design an algorithm and how to validate an algorithm. To answer these two questions, what we will take an example of calculator. For example, you have been given the problem to design a calculator. Now you will design an algorithm by taking the inputs. It should give me the output. You will follow the criteria of definiteness. That means no input should be given vague. Then you will follow the criteria of finiteness. You will take care of all these characteristics and effectiveness. After considering all these things, you are going to design the algorithm. Now, after designing the algorithm, you will analyze. Means after giving the inputs 0 or more, output, checking whether it is giving or not, then you will follow all these steps in order to design the algorithm. Now, after designing the algorithm, we have to validate. How you will validate? Sorry, before validating, we have to analyze. Analyze the algorithm of calculator in terms of space and time. How much space it is consuming and how much time it is taking to execute. Fine. After analysis is being done, you have to test the algorithms. For testing, test the algorithm before running it. You have to perform the debugging. After my program or after my algorithm is devised, you will convert it into the program before running it onto the system. Then obviously there will be some compile time errors or there will be some runtime errors. So you will solve them using debugging. Okay. After solving all those problems in the code, you will perform the profiling, code profiling. What is this code profiling? Basically, if your program is deviating from what it is expected to give as output, I repeat, if a program is deviating from what it is expected to give as output, then we will perform the code walkthrough. That is, we will try to analyze what kind of output is in each statement we are going to have. After going through the code line by line, we will devise the output for each line of code, that is called code profiling or code walkthrough. Okay. After that code walkthrough, we will be able to analyze time and space which would be taken by an algorithm after it is being executed. We will be able to analyze the time and space which will be there after we are executing the code. Okay. So we should be clear with the definition of two things: time complexity, because they are going to come in each and every algorithm. So it is the amount of time taken by the algorithm to get executed, algorithm or program to get executed. That is called time complexity, and it is always desired to have less time. Always desired to have less time. That means your program should be fast for any number of outputs. You should be fast for any number of outputs. Okay. Then is your space complexity. That is the total amount of memory. Total amount of memory taken by the program to execute. And total memory taken by the program, yeah, to solve or to get executed. And the memory will always be in terms of bytes, so it should be always less. It is also desired to have less memory. It is also desirable to have less memory. Okay, so this is how space complexity is measured. And time complexity, I have given you the definition of both. Total memory taken by the program to get executed is called space complexity, and total time taken by the program to run is called time complexity. And it is always desirable to have less amount of memory and less amount of space. For measuring the space and time complexity, we use asymptotic notations. These are of great importance in the subject, asymptotic notations. There are three types of asymptotic notations. That is three types of asymptotic notations. First is big O. So you will write as big O. And it is called worst case complexity. That is big omega. This is your best case complexity. And third is theta. That is average case complexity. Right? So this is worst case, this is best case, and this is average case. I'll try to explain all these three with the example of an array. Then we will go to the technical part. So we have an array of an elements. So how many elements are there? 1, 2, 3, 4, 5, 6, and 7. Fine. I'm going to perform the linear search. That means traversing the each and every element once. And I'm going to find any element. Suppose I have been given element 6 to find. Element 6 to find. So when I start traversing the index from 0 position, till the last position, right? I'll start matching the element from the location number 0. So when I went to location number 0, I found my element there. That is, I need not to perform any more comparison. So this is called best case. That means either your array is sorted or you find your element at the very first location. That means you need not to make many more comparisons. So that is called best case complexity. Whatever you are looking for is found at the location number 0, or your array is already sorted. Definitely you will get the smallest element without making the comparisons. So you'll find your element without making the comparisons. So this is called best case complexity. Suppose I'm looking for element 43 and it is not in the entire list. Since it is not in the entire list, I don't know. But I have to make the comparison. I have to start from the location number 0 till location number 6 to find whether 43 is existing. It is not there. That means we have made the maximum number of comparisons. Maximum number of comparisons we have made, or either my element is at the last location. Suppose instead of 3, it is 43. So that means I have made 6 comparisons in order to find the 43. Maximum number of comparisons I have done, or it is not in the entire list at all, or 43 is not present in the array. Since for looking, I have to make maximum number of comparisons, so it is called worst case complexity. This is called worst case complexity. Now, suppose I am looking for the element number 9, element 9. It is somewhere in the middle. That means I have to make average number of comparisons. 1, 2, 3 comparisons I have made and I have found it at the 4th location. So average comparisons. That means my element is somewhere in the middle or after the first location and before the last position. Your element will be here in this particular area, right from the location number 1 to location number index number 1 to index number 5. So it will make the average comparison. So it is called average case complexity, and it is denoted by theta. Fine. Best case is denoted by omega and worst case is denoted by big O. Fine. Worst case is denoted by big O and best case is denoted by omega and average case complexity is denoted by theta. So first asymptotic notation is big O. Represented by O, big O rather. So here we are saying, here we will take time and here we will take number of inputs for a particular algorithm. The input will start from 0. 0 or more inputs we are giving to an algorithm. As the input is increasing, the execution time will also increase. So I represented this function which is increasing with respect to n inputs is called fn. Okay. Now we have to find the function. Big O means maximum comparisons to be made. So that means upper bound. Upper bound. Maximum comparisons to be made. That means upper bound we have to find. That means we have to make a function which is always greater than this function for certain n where n naught is greater than equal to 1. For certain n naught which is greater than equal to 1. That means you have to find the function which is represented as c of g of n and it is always greater than f of n. Fine. So equation for this is fn is always smaller than c of g of n where c is equal to 1 and n is equal to n naught, which is greater than equal to 1. That means we have to find the upper bound, means what would be the maximum number of comparisons, or what would be the maximum time which would be taken by the algorithm for any number of inputs n. If we are giving the large inputs to the program, what would be the maximum time taken by the program to get executed will be determined by the function cgn. C is the any constant which is multiplied with the gn, and it is always equal to 1. You may take the bigger values, but minimum value of C would be 1. Okay. So we have to satisfy this condition. So I will take an example. Let me assume that this is my 3n plus 5. Fn is equal to 3n plus 5 and gn is n. Okay. This is given to me. Fn is 3n plus 5 and gn is equal to n. Now, how will I say f of n is big O of g of n? For that, I have to satisfy this condition. For that, I have to satisfy this condition. Fn is always less than c of g of n. For Fn, I am given 3n plus 5 and it should be less than n. Okay. Now, what constant I should multiply with n so that it should become 3n plus 5 should become smaller than n. Let's try. If I put n here, 1, 3n plus 5 is not less than n. Okay. Now, if I put 2n, 3n plus 5 is not less than 2n. I will put 3. 3n plus 5 is not less than 3 dot n. Now, if I put 4n, okay, and I put here 3n plus 5, now I say 3n plus 5 is less than 4n. Now, let us substitute the value for n. I have got my c as 4. Now, let us substitute the value for n. 3n plus 5 is less than 4n. Okay. If I substitute 1, if I substitute 1 into n, I will get as 3 plus 5, 8. 8 is not less than equal to 4 for n is equal to 1. Then substitute 2. 4 into 2, 4 into 2 would be 8. And here 3 into 2 plus 5, that is 6 plus 5 is 11. 11 is not less than equal to 8. Even for n is equal to 2, it is going to false. Now, I will assume n is equal to 3. 3 into 3 plus 5 less than equal to 4 into 3. 3 into 3 is 9. 9 plus 5 is 14. 14 is less than equal to 12. No. That means for n is equal to 3, this relation does not hold. Then let us go for n is equal to 4. 3 into 4 plus 5 is less than equal to, okay, 4 into 4. So 16, 3 4s are 12 plus 5 is less than equal to 16. False again. Now take n is equal to 5. 3 into 5 plus 5 is less than equal to 4 into 5. So 20 is less than equal to 20. That means it is not less than equal to, it is not less than, but it is equal to 20 is equal to 20. That means for minimum value of n is equal to 5 and c is equal to 4, I'll write here. For n is equal to 5 and for c is equal to 4, for certain constant n is equal to 5 and c is equal to 4, Fn is equal to big O of g of n. Fine. For input greater than 5 and constant value greater than 4, your Fn is big O of g of n. And this relation will fold hold for values greater than n is equal to 5. If I write n is equal to 6, so let us take substitute n is equal to 6 in 3n plus 5 less than we have said 4n. Okay, so 3 into 6 plus 5 and it is 4 into 6. 3 into 6 is 18, 18 plus 5 is 23 and it is less than equal to 24. 4 into 6 is 24. That means for the values which is upper than n is equal to 5, this relation will hold, this function will hold, that is c of g of n will remain greater for all values of n greater than 4, n greater than 5, n is equal to 5 and greater than equal to 5 and c is equal to 4. Okay, but now you can say, here we can write, you may have said 3n plus 5 is also less than 5n. 3n plus 5 is also less than 6n. Hence we conclude 3n plus 5 is also less than equal to 7n. So what happens? 5n, 6n and 7n. These are the three bounds. You may say that it is holding for it. But we have to always choose the tightest bound or the closest bound. We have to always choose the tightest bound or the closest bound, and closest bound is your 4n, 5n. So you will always choose the tightest bound, that is, you will say c is equal to 4 and n is equal to 5. So this is the tightest bound for which this relation will hold. Fn is less than equal to c of g of n. Okay, so we will say for values of c and n is equal to 5, this relation will hold for Fn is less than equal to c of g of n. So you have to always choose the tightest or the closest bound. Okay. See, from this graph, we will be able to conclude. See, this is f of n which is given to us. This is the upper bound graph which we are trying to find. Suppose my n is increasing. It was 0 here. For elements 5, I have told you that for n is equal to 5, the condition will be satisfied, that is Fn will remain smaller than c of g of n, because as you see this graph is becoming greater than Fn. Fine. And here is the time. So with respect, as n is increasing, the time gets also increased. So what would be the maximum time you can get from this peak? And this is called upper bound. Or in worst case, what could be the maximum time that could be taken by the problem to get executed? This is determined with the help of upper bound. Fine. See, I have given you the problem. Fn is equal to 2n plus 6 and gn is equal to n square. We have to prove Fn is smaller than c of g of n. Okay. So you will write 2n plus 6 here and it should be less than c dot n square. You have to find the value of c and n. See, if I put c as 1, the relation will become 2n plus 6 less than 1 dot n square, or it is equal to 2n plus 6 which is less than n square. Fine. So if I write, substitute the value for n is equal to 1, you will get 2 n is equal to 1. 2 into 1 plus 6 is less than 1 square. So 2 plus 6 is 8. 8 is not less than 1. Okay. Now put n is equal to 2. 2 into 2 plus 6 is not less than equal to 2 square. So 4 plus 6 is not less than equal to 4. Okay. So 10 is not less than equal to 4. So let's substitute n is equal to 3. 2 into 3 plus 6 is less than 3 square. 2 into 3 is 6. 6 plus 6 is 12. and here it is 9. 12 is not less than equal to 9. So it does not hold. Now I'll put 4. So n is equal to 4. 2 into 4 plus 6 is less than equal to 4 square. 2 fours are 8. 8 plus 6 is 14. And it is less than 16. That means for n is equal to 4, so this condition satisfies, it becomes true. So for n is equal to 4 and c is equal to 1, this relation will hold. Okay. For value of n greater than 4, this relation will hold forever. Okay. That means this function will be smaller.
Dear students, thank you so much for the patient listening. Thank you very much.